The question we are solving now belongs to test series 8. It is of network theory subject. In specific, it belongs to DC network solution methodology. This is a linked answer question. As per the question, there is a DC network as shown in the figure. It contains a 10 volts voltage source in series with a 10 ohm resistance. This combination is connected in parallel with a series combination of 10 ohm resistor and a voltage source, dependent voltage source of 2i1 volts, and the circuit contains another 10 ohm resistor and a load resistance RL connected between the terminals A and B as shown. This node is marked as 1. As per the question, we need to find the value of RL for maximum power dissipation in RL. We know that from the given network, for maximum power dissipation in RL should be equal to RTH. As the circuit contains independent source and a dependent source, RTH can be written as VOCAB, that is the open circuit voltage between terminals A and B, divided by ISHAB, that is the short circuit current flowing between the terminals A and B when these two terminals are short circuited. We need to find out VOCAB and ISHAB. Based on this, we can find the RL for maximum power dissipation. So for finding the VOCAB, let us redraw the equivalent circuit. Let us redraw the circuit as shown. So upon redrawing the circuit, we see that the terminals A and B need to be left open. So in this case, for finding the open circuit voltage, we see that the current I1 is flowing through the 10 volts voltage source and 2I1 as well. So from this we can write that I1 is equal to 10 minus 2I1 divided by 20. This is due to the reason that the drop across the 20 ohm resistor should be equal to the 10 minus 2I1. So upon simplifying this, we see that 22I1 should be equal to 10. That implies I1 is equal to 5 by 11 ampere. So from this we can say that the open circuit voltage VOCAB is equal to 10I1 plus 2I1, that is equal to 12I1, which upon simplification can be obtained as 60 by 11 volts. Now similarly, let us find out the short circuit current that is flowing between the terminals A and B. For finding the short circuit current, we can redraw the circuit as shown. So from this circuit, we see that upon performing the nodal analysis at node 1, we see that V1 minus 10 divided by 10 plus V1 minus 2I1 divided by 10 plus V1 divided by 10 should be equal to 0. And also from the circuit we can say that the current I1 should be equal to the drop across the 10 ohm resistor, that is 10 minus V1 divided by 10. So from this circuit we see, from these two equations 1 and 2 that we have just obtained, we see that the current I1 can be obtained upon simplification of 1 and 2 as 5 by 8 ampere. So from this we can say that V1 is equal to 15 by 4 volts. So the short circuit current ISHAB is flowing between the terminals A and B as marked, which can be written as V1 divided by 10, and this upon simplification can be written as 3 by 8 ampere. From this we can say that for maximum power dissipation, RL is equal to RTH is equal to VOCAB divided by ISHAB, and this upon simplification can be written as 160 by 11 ohms. That is upon substituting for the open circuit voltage of 60 by 11 volts and the short circuit current of 3 by 8 ampere. Hence the correct option, which represents the value of RL for maximum power dissipation, is D.